So let's start rational functions. We're going to graph them today. So you'll need your graphing calculator, so get it out. Make sure it's ready. Make sure your phones are away, Emma. Laptop should be down, so you're listening, Mr. Collins. Well, if you're following along, yes. If you're doing what you're normally doing, no.
I'm just following along. You see this? You see this?
I do see that, and you're doing well, but no. Okay? So, we're just doing these 2 bullet points for this section. Okay, we're going to graph rational functions, and we're going to find asymptotes, the vertical and horizontal asymptote. Remember, an asymptote, oh thanks, no, it's not for him. This one's for George. I'm going to give her one too now. You're so violent. Okay. Yeah, thanks for doing that. All right, anyway. So remember, asymptotes are a line that the graph approaches but won't intersect with, won't touch. Okay? And these rational functions, when we graph them, we're going to graph what is called a hyperbola. Okay? So here's the first type. All right? A rational function has the form f of x equals p of x over q of x. They're fractions. Rational numbers are fractions. Okay? So p and q are just 2 different polynomials. Okay? The q can never be 0, this polynomial, because are you allowed to divide by 0?
No.
No. So that's why it says that. P cannot equal 0. Okay? And section 7.1, which we skipped, talks about variation problems. And so an inverse variation is a fraction, basically. Okay? It's a rational function. So here's your parent rational function, y equals 1 over x. Remember when we first started the year, after we did a little review of some things, we started doing translations, transformations and stuff. Okay? Well, we always had parent functions, right? We had a parent function for lines. We had a parent function for our quadratics, and our cubics, and all that stuff. Okay? So the parent function for the rational functions is the y equals 1 over x. So if I put a negative 3 in for x, what's my fraction? Negative 1/3, right? When I put a negative 2 in for x, it's negative 1/2. When I put a negative 1 in for x, I get negative 1. When I put 0 in for x, what's 1 divided by 0? 0. No. Undefined. Can't be done, right? So you can never have 0 in that denominator. There's no answer. And then 1 divided by 1 is 1. 1 divided by 2 is a half. 1 divided by 3 is a third. Okay, so if I were to plot those points, negative 3, negative 1/3 is like there. Negative 2, negative 1/2 is like there. Negative 1 is there. Okay? If I put a half in there, what's 1 divided by 1/2? When I'm dividing by a fraction, it's like multiplying by its reciprocal. So that's 1 divided by 1/2 is like 1 times 2. So if it's negative 1, it would be negative 2, right? So negative a half would be negative 2. Negative a third will be negative 3. Okay? So what this graph here looks like, it goes like this. And what ends up happening, the y is our axis, is our vertical asymptote. and the x-axis is our horizontal asymptote. And we usually show, if we were graphing, our asymptotes as dashed lines. If I look at the positive ones, 1, 1 is here. 2, 1/2 is there. 3, 1/3 is there. Negative 1/2 would be positive 2. I'm sorry. Positive 1/2 would be positive 2 because multiplying by is reciprocal. Positive 1/3 would be positive 3. So this one looks like this. Okay. And at when x is 0, it's undefined. There's no answer. So that's our vertical asymptote. And I'm never putting 0. 0 divided by anything is 0, but it's always 1 up top, so we'll never have an answer of 0 for our y either. So our domain for this, when we talk about domain, which is what values? Yeah, a lot of times we say it's all real numbers, but which values does it represent, the domain? The x values, right? So the domain is all real numbers except what? 0, right? And the range, which represents our y values, are all real numbers except 0. That's where our asymptotes are. Okay? So the domain is all the real numbers except our asymptote. And the range is all real numbers except our asymptote. Okay? But that's called a hyperbola. It's got 2 sections. Okay? 2 branches, I guess is what they call it. All right? And again, if you go to your calculator, how do I graph something on my calculator? What button do I hit? Or y equals, right? So hit your y equals button. And if you got anything in there, clear it out. And just put 1 divided by x. Remember, x is second row in the middle. Hit enter. And then hit graph. And if your window's different, mine isn't, but you can kind of see them there. Kind of hard to see it, but it looks like the picture I did. Okay? If it's not showing that, hit zoom 6. That's our standard window. If your window's different, which, some problems we did a while back, we had changed the windows. So maybe yours is still in that different window. So zoom 6 will get you to what my picture looks like. Okay? So there it is. Those are the same, right? And again, if you need a table of values, how do we get to our table? Second graph, right? Second graph will give us our table of values. At 0, there's that undefined one, right? So there's our -3, -1/3, -2, -1/2, -1, -1, and 1, 1, 2 1/2, 3, 1/3. So the same numbers we got, right? They just wrote it in decimal form. Okay? So far, so good? Okay. All right, so again, parent function was f of x equals 1 over x for simple rational functions. It's called a hyperbola. All right, we said that already. But it's hyperbola. It's got 2 symmetrical parts called branches. The domain and range are all non-zero real numbers. Okay? For that. So any function of that form, a over x, like 1 over x, has the same asymptotes, domain and range, as this one, the parent one. Okay? So 4 over x just put in your calculator. Y equals, we're changing 1 to a 4. Hit enter. Oops, not clear. Graph, sorry. And there it is. It's just a little bit different. Okay? We could put numbers in if you want, but again, you don't have to. To get a table of values, hit second graph for your table, and it just same domain and range. Domain is all real numbers but 0. So x can be everything but 0, and same with the y. Our x and y axis are vertical and horizontal. We call them asymptotes, remember. Taylor, you have a question?
No.
Okay. We good? Is our calculators working all right?
Yeah, it's just when I go to hit graph, like every time it goes up to like a super high number, like it doesn't go to 0.
Okay, hit zoom 6. Oh, when you're looking at a table, you mean?
Yeah.
Okay. If your table numbers aren't giving you those right around 0, you can do this. Watch. If you look above window, it says table set. Window's right next to y equals. So hit second window, and you can start your table at whatever number you want. If you want to start it at -3 like mine is, that's just what's showing. And then hit enter. And then this means what increments, that little triangle in front of table, TBL, means what increments you're going on. Just make it 1. But we can go by halves or thirds. We can make it go by anything we want. Okay? But I always just put it by ones. Okay? So you just do that and then go back to second table. It'll start it at -3 for you. Is it back to it better? Or you could just hit, your down or up arrow key, whatever you need to get back to that area. Okay? Any other questions on calculator? All right, so that was 4 over x. All right? The next one was -6 over x. So what do you think is going to happen with that negative? Well, let's see.
It'll invert them to the other end.
Yeah, we've been in the first and the third quadrant. It's probably going to switch it to the second and the fourth. All right, let's see if we're thinking right. So -6 divided by x, we'll have to re-type it in because of the negative sign. Yeah, so it just switched the 2 quadrants. Our 2 branches are in the second and fourth quadrant now when our numerator is negative. And then again, if you need to see your table of values, hit second graph for your table. Same asymptotes, same domain and range. Okay. So, calculator helps us graph those if you have to graph them. Okay? Pretty easy stuff, right? When we have this graphing calculator, we might as well use it to help us, right? We're not quite there yet.
Yeah, we
All right, so it says graphing translations of simple rational functions. So this one's in a little bit different form, okay? But it's still a rational function. That's not what I want. All right, so this one's a little bit different here. All right, so we got a over x minus h is our fraction part, and then we have that plus k, all right? So it says draw the asymptotes, okay? Well, the vertical asymptote is whatever makes the denominator 0, whatever number you put in where h is. I guess whatever you put in for x to make it equal to 0, okay? So if this was x minus 3, then the vertical asymptote is positive 3. If it was x plus 3, the vertical asymptote would be negative 3. The opposite of the number here. Okay? Basically, it's the opposite of this number. All right? Whatever the k is out here, is the horizontal asymptote. Again, horizontal is this way, right? Verticals up and down, okay? So the opposite of this number, oops, that's not what I wanted. Right, the opposite of the H number is the vertical asymptote. And whatever K is, all right, whatever it is, +3, then that's your horizontal asymptote. If it says -3, it's your horizontal asymptote, okay? So they should have made that one the H for horizontal, but they didn't. And they should have made that a V for vertical, right? Okay? So, again, we're going to use our calculator. When you use your calculator, though, make sure you put parentheses around that. Okay? When you put it in your calculator, make sure you put parentheses around it. Okay? If you're like mine. Now, if you got the newer one, you might not have to do that, the parentheses. All right? One like Mason's, you might not have to. All right? So, I'm going to steal Mason's for a second, just to see. All right? So, I would have to, on my calculator, I would have to put parentheses around it. Okay? Okay? So, what's my vertical asymptote? What makes that 0? -2. What's my horizontal asymptote? Whatever that is, -1. Okay? That's a minus sign, but it's like a negative sign. Okay? So my domain then, okay, is x, all real numbers except -2. And my range then is all real numbers y except -1. Okay? So then, it's, for the vertical, it's always what makes the bottom 0, so it's the opposite, basically. All right? And for the horizontal, it's always whatever that is. So if that was a +1, this would have been +1. Since this is -1, it's -1. Okay? So vertical asymptote at -2, we have this dashed line here. Okay? A little higher, I guess. And then horizontal at -1 be like that. Since this is a -4 up there, what two quadrants will it be? 2 and 4, right? Now I'm going to use Mason's just for a sec to see what his looks like, the newer one. All right, so I'm going to go -4 divided by. Now it looks like we'll have to use the parentheses for this one as well. X + 2. So put that in parentheses like I have it, and then the -1. There you go, sir. Thanks. So again, on mine, I'm going to have to put it's y equals, and then I'm going to put, I got my negative there, so I'll just move over 4 divided by, and then parentheses, x + 2, close it off, and then the -1. And then hit graph, and you'll see we're in the second and the fourth quadrant. And if I were to put it here, make this a little bigger, okay? If I drew a dashed vertical line, when we say -2, right there's -2, you'll see that it doesn't touch that, And if I draw one at, what would you say, -1, that's here, right? There's the -1. There's our asymptotes that we figured out already by looking at it. Does that make sense? Pretty easy, right? We're almost there. All right, so where am I going to draw my vertical asymptote? Louder, Connor. Say that again. +1, right?
Yeah.
Remember, this is the vertical one, but it's the opposite of that number there. So +1 is right here. And what's my horizontal one? Yeah, whatever this is. And that's a +5, so that would be up here. Now, since my numerator is positive, where's my two branches? Top right, bottom left, right?
Yes.
Okay, so again, we just go to our y equals. I'm going to delete the negative sign. I'll put a 1 there. I'm just going to change symbols and numbers. Make sure it's in parentheses, remember? Okay, make sure that denominator part's in parentheses. Okay, and then hit graph. And it should look like we thought. Okay, if I move this out here and make it bigger. And draw those in. Okay, we said what? 1. Right here looks like the 1. And 1, 2, 3, 4, 5 is right there. All right, so there's our asymptotes. You don't see them on your calculator, but it's those spots we thought. Okay, remember, very important when you type it in that that's in parentheses, right? Right, William? I think that's it. Let me check. Oh, yeah, there's a little bit more.
Oh yeah, we didn't have part 2.
We got a part 2 section when they look a little different. So when they're in this form, it's real easy to figure out your asymptotes, your domain and range, right? All right, so when they look like this, a little bit different, okay? No plus or minus something after the fraction, like the last ones. It says the vertical asymptote is whatever makes the bottom 0. All right? If I set that equal to 0, I'd have to subtract the d over and divide by the c, right, to get x alone. So basically all you're writing to find the vertical asymptote is you're writing cx plus d equals 0 and then solving that for x. That's how you find the vertical asymptote. All right. The horizontal asymptote is those two numbers. Those two coefficients divided by each other. Okay? That's the horizontal one. All right? Which it says. Okay? And again, when you put this in your calculator, I would put both of those in parentheses. Okay? Put the numerator and the denominator in parentheses. That's important. So your calculator actually realizes it's that whole top part divided by the whole bottom part. You don't do that. Sometimes it thinks it's just a b divided by that. And if you don't put it down here, this may be B over CX it's thinking. Okay? So put them in parentheses. All right. So what makes this equal to 0? Positive 3. So just like before, right? Oops, not horizontal. I lied. That's supposed to be what? That's the vertical one. The denominator one is the vertical one. All right, and then the horizontal is this number over that number. What's in front of this bottom x? 1. So it's 2 divided by 1? 2. All right? All right. So this one, the equation is x equals 3. This equation is y equals 2. All right? So when I put in my calculator, remember, I put those are in parentheses. So go to your y equals, clear that out. Now parentheses, 2x plus 1, close it, divided by parentheses, x minus 3. So again, that's important. Parentheses around the numerator and the denominator. Hit graph, and that's what it looks like. Okay? So if I put it over here, and make it bigger, move it up, I guess. All right, so if I draw in x equals 3, vertical, 1, 2, there's the 3. We were on the right track, weren't we? And the horizontal, y equals 2, 1, 2, there's 2. We're in the right spot. Okay? Making sense? So a lot of it's just your calculator. But you got to put it in correctly. Those parentheses are important. Okay? All right, so what's my 1/2? Yeah. HA. 2/4 reduces to 1/2, so that's y equals 1/2. And then what makes this equal to 0 would be adding 2, right? And then divide by 4, it also becomes what? 1/2 or 0.5, right? That's our vertical one. Okay? Again, make sure when you put it in, you do that, and you'll get the right look. Our hyperbola is the graph of a rational function. 2 branches to it. All right? Hey, that's it now. There's your homework. The 3 means what?
Every 3.
Every third one, right? 3, 6, 9, 12, and so on. Up to 27. Hey, good job today.